Hi all, welcome to CodAffection. With this video, we are starting a series of videos implementing user authentication authorization with ASP.NET Core Identity in a Web API project. And hopefully we'll create a separate playlist where we'll be creating the client-side app in Angular or React with the same Web API that we are creating in this series. As always, I would like to start this video series by appreciating your support that you have done through the PayPal donations and other platforms. It really motivates me to bring more and more video series like this. So without further ado, let's get started with creating the Web API project inside this Visual Studio 2022. So first of all, create a new project. Select this template ASP.NET Core Web API. I will name this project as Auth EC API. Click on Next. Then select the latest installed .NET version. Then I will keep this authentication type as none so that you will know how to implement it from scratch. Now since we have a demo project here, I will uncheck this HTTPS configuration. Then I will keep this feature OpenAPI support as it is. This feature allows us to make use of the Swagger tools for testing the various endpoints that we create inside the Web API project. Now click on Create. So here we have the brand new Web API project. Before we go any further with ASP.NET Core Identity inside this project, first of all I want to talk about Identity and Access Management, abbreviated as IAM. Throughout this series, I will squeeze in as much as prerequisites like this to make you familiar and comfortable with ASP.NET Core Identity. So in short, IAM ensures the right people or machine or software components get access to the right resources at right time. Now, when it comes to authentication or authorization, it might not be always a person trying to access a secured or protected resource. It could be machines, for example, robots, and it can also be a software component. Now assume that you have a client-side app in Angular or React, and inside that app, say you want to retrieve all of the Facebook groups that a particular FP user has joined. For that, first of all, this client-side app must be authenticated to the Facebook developer auth system. In this given context, instead of a person, we have a software component that is trying to access the Facebook API. Instead of a normal FP user credentials like password with email or mobile number, this software component should be passing a different credentials which is first registered into the Facebook developer system. So in this given example, the client-side app acts as a software component. So in short, the party that is trying to access the protected resource could be anything in this range: people, machines, or software components. So IAM ensures that the right party get access to the right resources at right time. In brief, first of all, the party must prove that who they are or what they claim to be. A process in which they have to prove they are an insider. This is what we call authentication. More about that will be discussed in next video. This process in layman term we often call as login or sign-in operation. Now let's go ahead with the next step. Even when a party is successfully authenticated into the system, proving that they are an insider doesn't mean that they have the full access to consume the entire resources inside the protected system. The party could be allowed or denied to access certain resources inside the system. Now, this process is called as authorization. More about that will be discussed in the third video of this series. So a solution that fulfills these requirements is globally known as Identity and Access Management, in short IAM. For .NET applications, these are the available identity management solutions. Among them, ASP.NET Core Identity is the commonly used identity management solution for .NET Core applications. Now let's get straight into ASP.NET Core Identity. Now before getting started, I just want to let you know that the official documentation of ASP.NET Core Identity could be seen under this ASP.NET Core documentation inside this section, Security and Identity. And make sure to select the right .NET version from this dropdown. You could see the link of this official documentation inside the video description along with other important resources that I have referenced for this entire series. Rest of the prerequisites could be discussed when the right time comes. So with that being said, back to the Web API project, and let's look what we have inside this default Web API project. So everything starts with this program.cs file. So first of all, we have a builder object returned from invoking this method createBuilder from this web application class. Inside the builder object, we have this service collection. Into that, we'll be adding services that we need inside this Web API project. And from the same builder object, we have invoked this build to return the app object, which is then used for configuring the services that we have added into the service collection here. Okay, you could verify that here. As you can see into this service collection, first of all, we have added the controllers that transform this application into a Web API project. Otherwise, this would be a plain C# console application. And then with this app object, we can configure the services that we have added here. So for example, we have called this method map controllers so that all of the endpoints inside the various web methods inside this application will be configured into this project. Similarly, we have added the services for the Swagger UI here, and the same is configured here. Along with all of these methods, we have invoked this method use authorization. We'll talk about that later. And finally, with the execution of this run method, the entire application will be made available to accept the incoming request. So that's all we have inside this project. Now it's time to add ASP.NET Core Identity into this project. We have already discussed what is an identity access management and what it does. So the same is applicable to ASP.NET Core Identity also. Now let's be specific about what it does. ASP.NET Core Identity includes APIs, UI, and backend database configuration. So basically it allows us to manage user identities, storing user credentials, and granting or revoking permissions. And we are planning to implement these features in this video series. Now as part of this first video, we'll be creating user identities as part of user registration. Now along with these primary requirements, it supports external logins, two-factor authentication, password management, account lockout and reactivation, and support for authenticator apps. So all of these features are made available by ASP.NET Core Identity to the outside world through the APIs here. We just have to consume them with the required data passed to it, which are basically Web API methods. Now when it comes to a web application MVC, it also provides the front end with Razor pages, which I have already discussed in one of my previous video. Link will be there inside the video description under the heading related videos. And finally, we have the backend database configuration, which is basically Entity Framework Core models. So throughout this series, we'll be discussing how to make use of these services provided by ASP.NET Core and how to customize them as per our requirement to implement all of these features here. Now it would be more helpful if we understood the architecture of ASP.NET Core Identity in brief. We'll come to that in a bit. Before that, let's install the required NuGet packages into this Web API here. For that, right click on this project, then manage NuGet packages. Then inside this browse tab, search for this package, Microsoft ASP.NET Core Identity Entity Framework Core. Throughout this series, the install NuGet packages name will be there inside the video description along with other helpful instructions. You just have to copy paste from there. Now let's install this Identity Entity Framework Core package. Now since we are going to use SqlServer for this project, we have to install the corresponding Entity Framework package, which is EntityFrameworkCore.SqlServer. Let's install this. Now finally, in order to execute the migration commands, we have to install this package, EntityFrameworkCore.Tools. So these are the NuGet packages to get started with ASP.NET Core Identity. Now let's add the corresponding services into this program.cs file. Like this default project added the service for Web API controls. Now before doing that, let's get familiar with the architecture of ASP.NET Core Identity. So first of all, we have the data source layer for storing the data related to the entities inside the framework. In our project, it would be a SQL Server DB. Then we have data access layer. By default, it would be Entity Framework Core. And then just above that, we have identity store. It defines the structure and relation between various entities inside the identity solution. You could think of them as entity framework models, like users, rows, etc. All of them defines the ultimate structure of the table that is going to be created inside the data source. And then we have identity manager. For each entity we have inside the solution, such as user or rows, we have corresponding managers like user manager, role manager. So basically they consist of methods or handlers to implement the features that we talked about, like creating users, authenticating, authorizing users, etc. and etc. So these are the two layers that comes from ASP.NET Core Identity. Now in order to make use of them inside our ASP.NET Core Web API, we just have to add the corresponding services into our Web API project. So here we go, builder.services. First of all, we have to add this identity API endpoints. So this will add the various API endpoints from the identity core, which are handlers to implement various features that we talked about. Now while invoking this method, we have to pass the model class corresponding to the user entity. So that will be identity user. So by default, this is the class identity user, which defines what all things we need inside the entity user. So here you could see the default properties inside the user entity. We'll customize that in a bit. So first service is added here. So the service that we have just added is corresponding to this identity manager and the corresponding exposed web API methods. Now let's add identity store. Let me zoom in a bit. For that, we can invoke this method add entity framework store. So these are the two services that we have to add to make use of the identity core. Now while invoking this method, we have to pass the class corresponding to the DB context that we are going to use to interact with the DB, which we have not yet created. So let me create a new folder called models. Inside that, we can have this class app DB context. Normally, in order to define a DB context class, we inherit this entity framework class DB context. In case of identity core or ASP.NET Core Identity, we have to make use of this DB context class identity DB context. Now this becomes a DB context class. Now let me copy this and let's pass the same here. So here we have done with adding services from ASP.NET Core Identity into this Web API project. Now using the model classes that we have inside this identity store, let's create the actual physical DB inside the SQL Server. For that, we can just continue with the DB context class that we have just created. Now first of all, let's add the constructor like we used to add in any entity framework called DB context. Now here we have the corresponding parameter DB context options. Now we have to specify the DB context class as app DB context. Let's name this parameter as options. Now along with this constructor, we also have to invoke the base constructor, which is the constructor that we have inside this parent class here. For that, we can do this base then options. Now in order to create the physical DB with the existing default entities inside identity core, we have to do the migration. Now by the way, these are the entities that we have inside ASP.NET Core Identity. For each of these entities, you could expect a SQL Server table. Now before doing the migration, we have to inject an instance of this DB context class inside this program.cs file. So here we have the service. From that, we can call this method add DB context. Now if you don't know how dependency injection work, we can explain that in brief in a bit. Basically, it is a process of creating an instance of this passed class here. So in order to create this instance, we have to pass the argument corresponding to this constructor parameter here. So basically, it is expecting a DB provider based on the DB that we are using. So we'll pass the argument using this lambda expression. All we have to do is from these options, we have to call the method corresponding to the DB provider that we are using. Since we are using SQL Server inside this project, we can invoke this method use SQL Server. Into that we have to pass the corresponding DB connection string. So first of all we have to save that into this app settings.json file here. So here we go, connection strings. Inside that we'll have this key dev db. So this connection string is only for the development environment. So first of all we have the SQL Server instance name, and we have the DB name which is auth ecdb, and then we have these options. First of all, trusted connection is set as true. Now in order to enable the encryption we have set this option as true. Now finally, in order to execute multiple query batches simultaneously, we have set this option multiple active result sets. So that's all we have inside my DB connection string. Now let's pass this same into this use SQL Server method. In order to access the data that we have stored inside this app settings, we could make use of the builder object like this, builder.configuration. From that we can invoke this method get connection string. Into that we can pass the name that we have given for the connection string. Now we are ready for DB migration. Now before getting into that, let me briefly explain how dependency injection works in ASP.NET Core. So here we have injected an instance of this app DB context class, and here we have the default controller inside this app weather forecast. Inside that you could see this default web API method for a get request. The instance of this class here, this controller class, will not be created as by manually. It will be automatically created by the ASP.NET Core framework when a request reach up to this web API method here. So during the creation of such instances, if the corresponding class constructor is having a parameter which is of the type that we have injected here, then a corresponding instance will be assigned to the constructor parameter that we have here. Say for example, for this constructor, we have a parameter of the type app_db_context. When an instance of this controller class is created, an instance of this app_db_context will be passed because of this dependency injection here. We don't have to create the instance manually. So that's how dependency injection works. Now let's go ahead with DB migration. Before that, build the project. Make sure that there is no error. See, here we have a successful build. Now all we have to do is open the package manager console, which in my case it is inside this bottom portion of the Visual Studio. If you can't see it, select the project, then go to Tools, then NuGet Package Manager, then Package Manager Console. Now for DB migration, first of all we have to execute this command add migration, then provide a name, let it be initial migration, hit enter. As a result of this command execution, here we have a new folder called migrations. Inside that you could see the C# file with respective SQL Server commands which is to be executed to create the actual physical DB. Now in order to create the actual physical DB, we have to execute the second command update database. So here we have successfully done with the migration. If there is any problem in connecting with the physical DB, you could expect an error while executing this second command. So if there is any error, please recheck your DB connection string. Now in order to work with the database, I will be using the SQL Server Management Studio. Let's check whether the actual physical DB is created or not. So here we have the new DB. Inside that you could see the tables corresponding to the entities that we have inside ASP.NET Core Identity. So these are the tables corresponding to the default Entity Framework Core models that we have inside ASP.NET Core Identity. By default, all of these tables name will be prefixed with ASP.NET. Now let's check what are these tables stands for. So first of all, we have the table or entity user, which is having these properties or corresponding columns like username, email, password, phone number, etc. Then we have this role entity consisting of the collections of roles that we have inside our project, like admin, accountant, HR, etc. and etc. Then we have this user role, which is saying what are the roles assigned to a particular user. Now you can see this entity user claim and role claim. These are the additional informations that we can add to a user or a role. You will understand it better in the third video of this series. And then we have this user token representing the token assigned to a particular user. This will be helpful when it comes to our token authentication. What is meant by token authentication will be discussed in next video. And finally, we have user logins. It represents or store information about user logins, especially when it comes to external logins like Google, Facebook, etc. So that's all about the DB part to get started with this project. Now back to the program.cs file again. So these are the services that we have added from Identity Core, including the various endpoints to make use of the handlers inside the framework. In order to add the respective routes into this application, we have to configure this app object like this, app dot. We have to call this method map identity API. Here we have to specify the model class that we use for the entity user. So by default that will be identity user. Now let's run this app to see the various endpoints exposed from ASP.NET Core Identity. So these are the various web API methods or endpoints that we can make use of to implement the identity solution inside our project. Now the URL to this web API method will be like this, localhost, then this port number /register. Now since we are inside a .NET Core Web API, we have to prefix API just before this endpoint here. So API /register, API /login. In order to do that, we can do this just before mapping the identity endpoints. We can invoke this method map group, and inside that we can pass this /API. Let's build this project. See, that's it. Now in order to register a user, we have to consume this post web API method here, API /register. And it is expecting these data like email and password. Now if you only need these two information for creating a new user, you can make use of this post web API method. But in this tutorial, we also want to show you how to customize the identity as per your requirement. So in case of this user registration, along with these two informations, we also need the full name of the user. For that, back to the project. Now we'll create a new model class. I will name it as app user. Now we have to inherit this class from the identity model identity user. So along with the properties that is there inside this model class, we have to add this extra property for full name. Now let's specify the data type corresponding to the SQL Server column. So here we have the attribute column. Into that we can pass this type name. Let it be nvoc 150. Now you could see this green squiggly line here saying a non-nullable property must contain a non-null value. In order to disable this warning, just place the cursor inside this property, then expand this drop down, suppress or configure issues, configure severity, click on silent. Now ASP.NET Identity recommends adding the data attribute personal data to all the properties which are related to personal information of the user. Now let's copy this user class from here and let's update the same wherever we have used identity user so far inside this project. You could see all of them inside this program.cs file. First of all, we have the mapping for the identity endpoints, and then we have mentioned the same while adding the services for API endpoints. Okay, let me save this. Let's build this project. Build is successful. Now let's do the DB migration again for the newly created property here, full name. So open package manager console. First of all, execute this command add migration. I will name it as name is added in user entity. Hit enter. Finally, we have to execute this command update database. Sorry, we forgot the important step, which is adding a reference of this app user class into this DB context class here. Because when it comes to Entity Framework Core, everything will get connected through this DB context class. So if a new model class is added to the project and which is not added here, and then it won't be considered in future DB migrations. So all we have to do is just define this property dbSet for the model class app user. Now this property can be used for interacting with the corresponding table. So I will name this property as app users. Let's save this back to package manager. Let's re-execute the commands. I will name this migration as second try. Update the database. Back to the management studio. Refresh the DB. Let's expand the columns of this user table. So here is the new column, full name. Now during the user registration process, along with these details, we also have to pass the full name. So instead of using this default web API method, we're gonna create a new post web API method for user registration. That we can do inside the program.cs file itself. Later we can organize everything into respective files and folders. Instead of conventional controls like this, we're gonna use minimal API controllers inside this project. With this new minimal approach, it is really easy to create new web API methods and way more satisfying than conventional controls. So in order to create a post web API method, all we have to do is from this app object, we just need to call this method map post. So this becomes a post web API method. Now as a first argument, we'll pass the URL. It will be API/sign up. And here we have the corresponding callback to handle this request. As per the current setup of Identity Core, there is no straightforward method to reuse this URL. And with the current version of the framework, we can't extend already existing implementation of the verb methods from Identity API. Could be made available in upcoming versions. So that's why we have created a separate URL here. Now talking about the actual implementation, hope you know that ASP.NET Core Identity is an open source project. You could see the actual source code inside the GitHub repository here. And if you want to see the actual implementation or source code of these identity web methods inside this project, you can search for this file, Identity API Endpoint Route Builder Extensions. Inside that, you could see the actual implementation of the web API methods that is available inside the project by default. So for example, if you want to see the actual implementation of the web API method, which is responsible for the registration of a user, here is the web API method. And for login, you could see the post web API method here. So like that, most of the web API methods that is exposed from the identity solution by default could be seen inside this file. Back to the topic. Now let's handle this post request inside this callback. First of all, we have this parameter user manager. Along with this manager, we also have to pass the model class for the user entity. That will be the new class that we have created, app user. We'll name this parameter as user manager. Now we need a second parameter to accept the user information that is passed through the body of this request. For that, I'm going to define a class like this, user registration model, after executing or invoking this run method here. Don't worry, we'll organize everything in next lecture. So this class represents the properties that we expect through this post web API method, email, password, and full name. Now let's add the second parameter accordingly. From the body of this request, we expect the properties that we have inside this class, user registration model, and we'll name this parameter as user registration model. From where do we get an instance of this user manager class? Now we need this user manager to do any operation related to user. In this case, we have to create a new user. We have already seen this class user manager while explaining the structure of the identity solution. Identity manager layer consists of these manager classes. We have already added the respective services with this method add identity API endpoints along with adding the entity framework stores. So an instance of this user manager comes from the dependency injection that is done with these two method invocations here. Like we have seen with the DB context clause, the dependency injection is done here, and from there all the classes having a constructor parameter of this type will be assigned or shared with an instance from the dependency injection that we have configured here. Similarly, the dependency injection done for the manager classes will share an instance for this user manager parameter here. Now let's go ahead with user creation process. First of all, we have to create an instance of the model class app user. First of all, we have email and we'll assign the corresponding value from the body that we have passed to this post web API method. Now similarly, we have to assign the full name. Now in order to create an user, all we have to do is from this user manager, we can invoke this method create async. Inside that we can pass the user object that we have created. Now as a second argument, we have to pass the password. That's why we have skipped passing the password into this app user object. Now let's pass the same from this registration model password property. Now since we have an async method here, we can prefix this method invocation with the keyword avoid. At the same time, you could see that this async keyword is automatically added here. Now we have to store the return object from invoking this method into this variable result. Now based on how this operation is carried out, we can return the response from this web API method. For that, we can have this if clause. If this operation is successful, inside the result object will be having a boolean property succeeded. It will be set as true. In that case, we can return the response like this. Results.ok method can be called. Inside that we can pass the result object. So this will return the response with a status code 2.1 indicating the user is successfully created at the web API. Else, we'll return the response like this. Instead of OK method, we'll invoke this method bad request. Now this is all we need for creating a new user inside ASP.NET Core Identity. Now depending upon your future requirements, you can extend this web API method. For example, if you want to verify the given email address from the user, you have to make the required changes inside this web API method. Okay? Now let me build this and let's create a new user. Now inside this Swagger UI, you could see the new post web API method that we have created, API/signup. Click on try it out. So first of all, we have the email address. For now, let's keep this password as it is, string. Then we have full name. Click on execute. You could see that we have got a response with the status code 400, meaning that a bad request is sent from our client side here. So here we have the response body having succeeded property is reset as false. To see the actual problem, you could inspect this errors array. So basically these are the errors or validation errors for the password that we have passed. So by default, the password must have at least one alphanumeric character, meaning that there should be at least one special character inside the password, then at least one digit, one uppercase. Now if you want to keep these validations as it is, you can do that. But if you want to customize these validations, you can do that also. So inside this program.cs file, with this builder object, we could do this builder.services.configure method can be called. And here we want to configure the identity options. This collection of services can also be used to configure like we configure with the app object here. Along with adding services, it will also be used for configuring the added services. So here we go. We have this lambda expression with this options parameter. Options.password. Inside that you could see the various validations applied to this password property. So first of all, I want to disable this validation for required digit. Let's duplicate this. Let's disable the validation related to the uppercase and lowercase requirements. Now along with all of these, I want to enable a new validation. It goes like this, options.user. Inside that, I want to set this require unique email as true. By default, it is false, so no user can have same email address. Okay, so with that being done, let's build this project again. Let's try to create a new user again. Now let's specify the password. Now by the way, these are the default validations applied to the password property. Required digit, which we have already disabled. Then we have the min length validation. At least there should be 6 characters. Both of these validations, lowercase and uppercase, are already disabled. And we have to keep this at least one special character requirement. And finally, you could see this unique character validation, which at the moment is set as 1. So technically it is disabled. Now suppose if it is assigned with a value more than 1, say 2, then passing a password like this, repetition of same character is not allowed. There should be at least 2 distinct characters. So that's what this validation implies. When it is set as 1, technically it is disabled. So at present, we have these 2 validations, minimum 6 characters, and there should be at least 1 special character. So here we go, string, then I will add this special character. In total, we have 6 characters. That's enough. Now let's provide a full name. Click on execute. Now you can see another error here saying that username is invalid, can only contain letters or digits. Now as per the default identity model implementations, the username can't be blank. For this particular identity solution, we are not asking for the username. Nowadays, most of the application is not asking for username. Instead, they use email address. If you have such a requirement where username is required, you can pass that and do the required changes inside the web API method. Okay. Now in order to disable this error, we often pass this same email address into the username property. Now before making the changes inside the web API, first of all, let me copy this object to the clipboard. We'll need that for the next try. So here we go. Along with passing the email, we'll pass username with the given email address here. So that will solve the problem. Save this, build the project, back to the Swagger UI. Making changes inside the web API will reload the page, and that's why we copy the last user object. Click on try it out and let's paste the same here. Click on execute. Boom. So here we have successfully created the user inside the ASP.NET Core identity. Let's verify the same inside this user table. See, here we have the new user with given credentials. You won't see the password that we have passed. Before saving it, it will be hashed into a format like this. So that's all for this video. In this video, we have given the overall introduction to ASP.NET Core Identity, and we have done an in-depth explanation on creating a new user or user registration with ASP.NET Core Identity. In next video, we'll be discussing user authentication in great detail, especially with JSON Web Token. Once it is done, you could see the link in video description and inside the first comment of this video. You could download or clone this project from the GitHub repository link given below in video description. If you haven't already subscribed to the channel, please consider doing it now. Please like and share this video with your friends and colleagues so that they can also benefit from this. Have a nice day. Bye.